Assalamualaikum warahmatullahi wabarakatuh. Today we from group 2 will present about our project which is DC motor. Our group consists of 3 members which is AMIRUL ISLAN bin ISMAIL, MOHAMMAD HAIRIE bin ROHALIN and me, Muhammad Rafie bin Bahrin. For the introduction, a DC motor or direct current motor is an electrical machine that transforms electrical energy into mechanical energy by creating a magnetic field that is powered by direct current. When a DC motor is powered, a magnetic field is created in its stator. The field attracts and repels magnet on the rotor. This causes the rotor to rotate. To keep the rotor continually rotating, the commutator that is attached to brushes connected to the power source supplies current to the motor's wire winding. And our objective of our project is to build and test the DC motor model with different turns. To build our DC motor model, it requires a dry cell, copper wire, black tape, a magnet, 2 large metal paper clips, fine grit sandpaper, and a scissor. And this is our final product. And we will calculate the current using the multimeter. And this is the result for the 5 steps. Next, this is the current for the 10 turns. And lastly, this is the current for the 20 turns. And this is the schematic diagram for our model. So for the question related to our project, how does the coil rotate? The closed loop circuit can carry current from the negative terminal of the battery to the positive terminal. Also, it has its own magnetic field. So by the information that we have gained, we know that the current does induce the magnetic field in the coil, and by the help of the magnet, the coils will repel and put spin in one direction constantly. Second, does your motor rotate in both directions? If yes, explain, and if no, explain. Suggest 2 methods in determining the rotation direction of the coil. No, because the commutator breaks the current at the right time, because otherwise the motor would stick, and when the current flows again, the motor is again drawn towards the coil. Repeat, and we just have motion in one direction only. Reversing the direction of current flow is the only way to reverse the spin of the motor. 2 methods in determining the rotation direction of the coil is by using Fleming's right-hand rule and curl right-hand rule. The third question, does the height of the magnet of the coil affect the current magnitude and the speed performance of the motor? Yes, the height of the magnet to the coil affect the current magnitude and the speed performance of the motor, because the closer the magnet to the coil, the strength of the magnetic field increase. For the fourth question, does the number of coil turns affect the current magnitude and the speed performance of the motor? Yes, because when the number of turns in the coil increase, an iron core will make a strong electromagnet which can be easily magnetized and demagnetized. So a coil with 20 turns would produce a greater magnetic field intensity than one with only 10 turns. For the fifth question, how could you increase the speed of the motor? We can increase the speed of the DC motor by running it at a higher voltage, using a stronger magnet, increasing the number of turns of wire in the coil, reducing friction between the coil and the axle it rotates on. For the sixth question, what would happen to your motor if you switch the direction of the current? If we switch the direction of the current, the change in the flow of current switch the direction of the spinning force, causing the motor shaft to begin turning in the opposite direction. For the last question, discuss how the connection of the multimeter in order to measure the current flow in the coil. The measurement of the multimeter in our project is in series circuit. The two probes of the multimeter must be attached or touch the clip holder of the coil, so we can see the reading of current through it. As for the conclusion, a DC motor or direct current motor is an electrical machine that transforms electrical energy into mechanical energy by creating a magnetic field that is powered by direct current. A shunt or separately excited DC motor has a torque speed characteristic whose speed drops linearly with increasing load torque. Its speed can be controlled by changing its field current, its armature voltage, or its armature resistance. So that's all from me. Thank you.